In this lesson, we're going to be focusing on how to graph log of quadratic expressions. In addition, we're going to be finding the domain and range of each of the questions we're going to solve. Let's start with this. Y is equals to log s squared base 2. Let's graph this function and find the domain and range. The first thing we're going to do is to find the vertical asymptote of this function. And to do that, we're going to set the inside of this logarithm function to 0. So we have s squared is equals to 0. Then if we solve for x, let's take square root of both sides. Then you see that x is going to be equals to 0. The second step we're going to take is to find the domain of this function. And then to find the domain, we're going to set the inside again to be greater than 0. Reason is because we can't have 0 inside a logarithm function. Log 0 base 2 is undefined, so any number that must be here must be greater than 0. Now we have s squared is greater than 0. What do you find out here? You see that this is s squared. If you plug in a negative number here, this square here will turn it to a positive number. If you plug in a positive number, it will still be a positive outcome. For example, if you have minus 2 square, we are going to get 4. If you have minus 4 square, we are going to get 16. The same thing if you have 2 here, 2 square, you will have 4. And if you have 4 square, you will have 16 here. So what does this tell you? It tells you that the domain of this logarithm function is going to be all real numbers excluding 0, because 0 is not part of the domain. Any number that is the vertical asymptote is not going to be part of the domain. So the domain of this function is going to be equals to all real numbers excluding 0. So it's going to be negative infinity to 0, union 0 to infinity. This is all real numbers excluding 0. So that is the domain of this function. But how do we graph it? Let's make a table of values, and it's going to have x and y values. Now x are going to be part of the domain of this function. We are going to pick 2 values of x that fell within this region, and then 2 values that fell within this region. So let's pick minus 2 and minus 4 here, and then for this region we pick 2 and 4. Now we have y is equals to log s squared base 2. If you have log, now here if you plug in minus 2 here, minus 2 squared is going to be equals to 4. So you have log 4 base 2, and then log 4 base 2 is going to be equals to 2. Now if you plug in minus 4 here, you have log minus 4 squared is equals to 16. You have base 2, and then log 16 base 2 is going to be equals to 4, because 2 raised to the power 4 is equals to 16. Or you can simplify it this way. We have log 16 is equals to 2 raised to the power 4. Then we have base 2. By the time you take this 4 to the back of this log, you have 4 log 2 base 2. And then log 2 base 2 is equals to 1. 4 times 1 is equals to 4. So we have 4 here. So notice that if you solve for this 2 and 4, it still gives you the same answer that this minus 2 and minus 4 gave, which is equals to 2 and 4. So let's go ahead and graph it. So let's draw the graph and then indicate the vertical asymptote, which is at x is equals to 0. So here is it. That's x is equals to 0. Then let's plug these points. When x is equals to negative 2, y is equals to 2. So here we have x to be negative 2 here, y is equals to 2, so which is this point. Then when x is equals to negative 4, y is equals to 4. So here is negative 4, then here is 4, so somewhere here. So when x is equals to 2 again, y is equals to 2. When x is equals to 2, y is equals to 2. And when x is equals to 4, y is equals to 4. So somewhere here. Now let's connect the dots. So my curve may not be perfect because this is just a sketch, but it can be understandable. So this is it. So this is the graph of this function log s squared base 2. And then we have negative infinity here, we have positive infinity here, we have infinity here, we have negative infinity here. Now to write the range of this function, we have already found the domain. To find the range, so the range is from negative infinity to positive infinity, that is all real numbers. So that's the range of this function, and then here is the domain. Let's have another example. Y is equals to log s squared minus 9 base 2. Graph this function and find the domain and range. Pause this video and do this. When you are done solving it, you unpause it and watch. So the first thing we're going to do is to find the vertical asymptotes. Let's set the inside to 0. We have s squared minus 9 equals to 0. Then this can be treated as difference of two squares equals to 0. So we're going to have x plus 3 multiplied by x minus 3. All of this will be equals to 0. Now we have x plus 3 is equals to 0, or x minus 3 is equals to 0. If you solve for x here, you see that x is equals to negative 3. And then if you solve for x here, you see that x is equals to 3. So the vertical asymptote is going to be equals to 3, negative 3. So this is the vertical asymptote. Next thing is to find the domain of this function. To find the domain, we set the inside to be greater than 0. So we have s squared minus 9 is greater than 0. Let's find the critical values first. So the critical values can be found by just equating this to 0. We have s squared minus 9. If you equate it to 0 and solve for x, you get your critical values, which is what we have gotten here, which is x is equals to negative 3 and x is equals to positive 3. So let's draw a number line and indicate those critical values. We have negative 3 here, we have positive 3 here. Now notice that on this number line we have 3 regions here. This region which is from negative infinity to negative 3, this region which is from negative 3 to 3, and then this region which is 3 to infinity. We are going to test each of those regions to know the one that can actually give us a values that are greater than 0. Because of this domain, the number must be greater than 0. So let's plug in negative 4, because negative 4 fell within this region. So if we plug in negative 4 here, negative 4 plus 3 is equals to negative. Negative 4 minus 3 is equals to negative. Negative times negative is equals to positive. So here give us positive. Let's choose a number that's between negative 3 and 3. Let's choose 0. 0 plus 3 is equals to 3, which is positive. 0 minus 3 is equals to minus 3, which is negative. Plus times minus is equals to minus. So this region gave us minus. Now let's pick a number that is from this region. Let's pick 4. 4 plus 3 is equals to 7, which is a positive number. 4 minus 3 is equals to 1, which is a positive number. Positive times positive is equals to positive. So here gave us positive. Now we can see we're going to discard this region because this region gave us a negative number. But the number we want is the one that will give us greater than 0. So this positive region and this positive region are what we want. So from here we see that the domain of this function is going to be from negative infinity to negative 3, then union from this 3 to infinity. let's make table of values, and then we're going to pick numbers that are within the domain of this function. So we're going to go with -4, we go with -6, and then we go with 4 and 6. If you plug in -4 into this logarithm and solve for y, we're going to get 2.8. Then if you plug in -6 and solve for y, we're going to get 4.8. Then if you plug in 4, you still get the same 2.8, and then 6 again, you get 4.8. Because this is s square, any negative, it will convert to positive. If you plug in positive of that number, it will still be positive. So let's graph it. We have 1, 2, 3 here, we have 1, 2, 3 here. Let's indicate the vertical asymptote at x is equals to 3, which is here, and then at x is equals to -3, which is here. So when x is equals to -4, y is 2.8. So this is our -4. Then y is 2.8. We have 1, 2. Then 2.8 is somewhere within this region. Then we have it here. When x is equals to -6, y is 4.8. Let me extend this line. We have 1, 2, 3, 4, 5, 6. And then we have 1, 2, 3, 4, 5. Now when x is equals to -6, y is equals to 4.8. So here is -6. We have 1, 2, 3, 4. 4.8 is within this region, so that is here. And then when x is equals to 4, y is 2.8. We have 1, 2, 3, 4. 2.8 is somewhere within this region. And then when x is equals to 6, y is 4.8. So this is 6 here, and then 4.8 somewhere here. So let's connect the dots. So this is going to be like this, and then this one is going to be like this. Remember, this line here never touches the vertical asymptote, but it will keep on getting closer, but it never touches it. Okay, so this is the graph of this function. Let's write out the range. So the range is just from -infinity to +infinity. That is all the numbers. Then this is the domain. Domain, we just remove the first vertical asymptote and then the second vertical asymptote. Any number that fell within this region is not part of the domain of this function. And here are the numbers that we removed. So this is it for this video. Thank you for watching. Please don't forget to like this video, share with your friends, and drop your comments. Have a wonderful day.